Hi, my name is Nuria Lorenzo Dus, and I am the Dean of Postgraduate Research at Swansea University. I hope that you are keeping healthy, well and safe in this difficult time. Today, I am delighted to welcome you to the 2020 edition of Swansea University's 3-minute thesis competition final. So, what is this 3-minute thesis competition? What is 3MT? 3MT is a postgraduate researcher international competition that was first established by the University of Queensland in 2008. At Swansea, we've been running 3MT since 2014, and we're now part of about 70 UK-based institutions that form a global 3MT network. The main purpose of this network, I'm going to be quoting from the official website, is to showcase to a variety of audiences the quality and diversity of research being undertaken by postgraduate research students. However, I can tell you that this description does not do justice to what 3MT is, because 3MT is about bringing research to life, to postgraduate researchers' lives and also to your lives as the audience. And how do they do this? Well, 3MT is about brevity. So each contestant has 3 minutes, no more, no less, to describe their research. And to make it even more exciting, they only have one slide to support their description. 3MT is also about impact, about the real impact that postgraduate researchers' work has on our world. And 3MT is about clarity. It's about being able to describe knowledge, the knowledge that is in your research, in a way that just makes sense. No wonder, therefore, that 3MT is always the highlight in the postgraduate research calendar. At least it is for me, and I'm sure for many of you. So this year, the qualifying rounds took place on the Singleton and Bay campuses at the start of March. And they were judged by a panel of expert communication and public engagement colleagues. Rhian Morris, who's the chair of Swansea University's Public Engagement Forum, Dr. Chris Marshall, who's the Director of Knowledge Economy at the Hillary Rodham Clinton School of Law, and Caroline Reuter, who's a Scholarly Communications Officer from the Information Services and Systems Department within the university. Since then, we had to make some changes and some arrangements because of the current COVID-19 crisis. Usually, the final, this event, takes place in a beautiful venue on the Singleton campus, the Taliesin Theatre. This year, this is not possible because of the necessity to work remotely. So what we did is the top 10 scoring presentations from the qualifying rounds were selected, video recorded, and further judged by a panel which comprised the directors and the deputy directors of postgraduate research in our 7 schools and colleges. So this year, the panel comprised Professor Maurizio Piai from Science, Professor Janie Rans from Human and Health Sciences, Dr. Catherine Jones from Arts and Humanities, Dr. Martin Clift from Medicine, Professor Dave Penny from Engineering, Dr. Caroline Jones from Law, and Sean Roderick from Management. The recordings have been edited into this Swansea University 3MT Final 2020 competition video. Please note that one of the finalists has asked us not to include her video because of the nature of her research. So the video that you will be seeing only contains 9 presentations. The video will show each of these presentations, and it will be followed by an announcement of the winner and the runner-up and some closing words from Jill Burgess, who is a member of council at Swansea University. So let me just wrap up this opening remarks, first of all by thanking our postgraduate research students who entered this competition, also Jill Burgess for announcing the winner and the runner-up, as well as the judging panels and also the fantastic team in the Postgraduate Research Office who's provided all the support to make sure that we could run this event this year. Let me also reiterate what a great event 3MT is. Be ready to be amazed by the originality and the value of the research that is covered across the 9 presentations. Be ready to be impressed by the sheer communicative talent, professionalism, and confidence of our contestants. Enjoy the video and please stay well and safe.
So, first of all, what is a looked after child? Well, it's a child that has been placed under the care of the local authority, either in a foster care setting, can be getting adopted, or can be put in a residential unit. These children are usually placed there as a result of abuse or neglect, or can actually be as a result of parental incarceration or disability. So what do we know about this group so far? Well, it's a pretty bleak picture. Apart from being predicted to attain really poor health and social outcomes in poverty, poor mental health, physical health, they are 9 times more likely to have a special educational need and 4 times more likely to have a mental health disorder. Now, we know that psychiatric disorders are much more higher in this group, but they're normally presented under very broad categories such as mental, developmental, or behavioural disorders. What's limited in research is what specific disorders fall under these umbrella categories. So my thesis is going to use different methods to explore the impact and prevalence of neurodevelopmental disorders in this group. These disorders, such as ADHD, autism, dyslexia, are lifelong and can impact dramatically on the child. They can significantly impact their ability to socialize, their ability to learn. It affects their memory and also affects their mental health. Furthermore, what is really important is that these children cannot be supported using the usual generic support services. They require specific, specialized support services. So I've conducted a systematic review, and so far, from my results, there is some association to suggest that if you are a looked after child, you are more likely to be diagnosed with ADHD compared to your peers. Now that raises quite a few questions for myself and for research. Are these children being overdiagnosed, misdiagnosed, or are these indiscriminate disorders actually more prevalent in this group? And if so, why? What was also worryingly was the outcomes that are associated with the child as a result of having these disorders. I'm talking about higher risk to physical and sexual abuse. So my next step of my thesis is going to interview social workers to gain their front-end experience to further understand what the needs are of these children to help improve their future health and social outcomes. Thank you.
I bet when you come inside this room, you've already picked out which faces are attractive, healthy looking, and who may be in your age range. Research show that these traits influence our social interactions, especially when we're looking for friends and intimate partners. Interestingly, these traits also drive the increasing demands in cosmetic industry. But faces come from different ethnic groups, and research show that an other ethnicity effect exists, where people from your own group are recognized better and are given higher ratings of positive traits compared to people from other groups. Interestingly, we used to think that standards differ from one group to another. But research from evolutionary psychology show that there are universal standards of beauty, facial health, and facial age. In other words, most people would agree on the ratings for these traits on a certain face. But how do we look at a face and come to a judgment? Past research using recognition tasks show that Caucasians look at Caucasian faces differently than when they look at Asian and African faces. I want to know whether this also happens when we make judgments on someone's attractiveness, facial health, and facial age. To do this, I am recruiting Caucasian and Asian students to look at Asian, Caucasian, and African faces while having their eye movements tracked. I asked them to rate these faces on attractiveness, health, and age separately. In group comparisons, I would expect that there is an other ethnicity effect while having a high agreement on individual faces. To complement these results, I will also be recruiting women from different ethnic groups between the ages of 25 and 65, measure their skin properties, and ask their opinions about cosmetic procedures. I expect to see that there are significant differences in the facial skin properties between ethnic and age groups, and that women between 35 and 55 are more likely to want to engage in cosmetic procedures. This research could shed light into how we are biologically wired to look at faces. Knowing which facial areas people use when making these judgments could help tailor interventions when we're enhancing facial appearance. This will also highlight the needs of people from different ethnic backgrounds. And although controversial, more people engage in cosmetic procedures, particularly middle-aged women. It is therefore imperative that we know how to create interventions that will lead to natural-looking and more efficient results, which will lead to better well-being later in life. Thank you.
Hi everyone. Would you rather be injected with a hypodermic needle which causes you pain, bleeding, and infection? Or would you rather use a microneedle which you can barely feel on your skin? Microneedles are made out of polymer adhesive, also known as medical glue. So they are softer on your skin, as well as they are only 0.6 millimeter in height. 0.6 millimeter in your outer layer of your skin doesn't come into contact with any of your nerve endings, any of your blood vessels. That's why it's pain-free, it doesn't cause you bleeding, or it doesn't cause you any infection. So how does a microneedle actually work? When you apply into the outer layer of your skin, it makes little pores into your skin. So when you put a pharmaceutical drug on top of it, such as insulin, vaccines, or collagen, it can easily diffuse into your skin, going into your body. So in my research, I was able to optimize the process of making these microneedles, making them sharp, strong, and precise. So they can easily form those pores into your skin so the drugs can go into the skin. Looking at the microneedles, they have a lot of advances in the future, as you can replace that with, you won't have to have injection with insulins into your body. You won't have to have vaccines. And because of the fact they're so soft and they are literally, you won't be able to see what the microneedles are, what are in the content, you won't be able to have any fear towards it compared to an injection. Looking at these microneedles, so how are they actually formed? So they're formed using, if I tell you, they are formed using the same process you can print on your t-shirt. So what we have is we have a screen, we have the polymer. The screen has a squeegee which passes those polymer through the screen, and the screen itself has little tiny holes where the polymer goes into. As the polymer goes, it goes from one level to another level, slowly forming a higher peak. So in my research, I was able to look at different settings, such as looking at different squeegees, looking at different hardness, looking at different speed, looking at different print gap to make those microneedles sharp and precise so you can easily inject into your skin. So hopefully in the future, with the development of microneedles, you won't have to worry about having any pain, any bleeding, because microneedle will barely feel anything at all. Thank you.
Have you ever thought to which extent plastic is part of your life? Look around. Mobiles, computers, furniture, clothes. This shirt made of polyester, of plastic. Our society has relied on these materials to continue growing. They are versatile, resistant, light, and cheap. As a famous song says, "I'm a plastic, it's fantastic." However, plastic could be one of the most important problems that humans will face this century. One of the most important issues is that they don't are biologically degraded. They just break down into smaller and smaller particles called microplastics and nanoplastics. And these are the real bad guys. You probably know that we are consuming microplastics found in the animals we eat, but did you know that we are also drinking and breathing them? You open a tap, enter any room, and there they are. Did you know that we are consuming a credit card's worth of plastic every week? Plastics are everywhere. Air, soil, water. It's not raining men anymore. Guess what is raining now? Exactly. And there is something even more scarier. They are thought to be entering the animal cells and releasing chemicals that can alter the cell functionality. And we are animals. To this in the front of us, we are now only starting to understand the huge challenge that we're dealing with. The first step is to identify and quantify micro and nanoplastics in the environment, but there isn't still a proper technique to do that till now. As part of my research, I have published a new procedure for the identification of these particles in water samples. I filter the samples through membranes with a very small pore size to retain the plastics. I then heat them up to a temperature high enough to decompose the plastics, but not the membrane itself. And the volatile components are then identified and quantified through, using chromatography and spectrometry. These fragments, these volatile fragments, are unique to each plastics, so they will determine whether the plastics is within this sample or not. Unlike other techniques, this one allows you to identify plastics in a complex mixture and also increase the detection levels. Now that we know how to detect plastics in a concrete environment, we can now focus on the next step, how toxic micro and nanoplastics are. As always, show must go on. Thank you.
We all get stressed, right? But have you ever noticed how you start to feel stressed whenever someone close to you is also feeling stressed? Perhaps they have a looming work deadline or an important interview? This phenomenon of sharing stress is known as cortisol co-regulation. Cortisol is the hormone responsible for activating your stress response when you come across something stressful. In cortisol co-regulation, both individuals in a social pair, like romantic couples or mother-infant pairs, will influence each other's cortisol levels. Cortisol co-regulation, though, has also been identified in a species of small fish, which is pretty cool. So co-regulation tends to be stronger when we spend more time with each other, but this can also be the case when our relationships become strained. So this means that the function of co-regulation varies in different contexts. Now, as well as mothers and infants and pairs of fish, what if I were to tell you that cortisol co-regulation can actually occur between two completely different species? This is the focus of my PhD thesis, to identify and understand cortisol co-regulation between different species. Dogs and their owners are a perfect pair to look at this between species co-regulation. We have lived alongside the domesticated dog for almost 12,000 years. And the bond we form with our dog is often likened to the bond that exists between mothers and infants, a bond where we've already identified co-regulation. So, I collect hair samples and saliva samples from dogs and their owners, and then I go away to the lab and I analyse the cortisol concentrations in these samples. And so far, my preliminary results suggest that co-regulation does occur between dogs and owners, but that it actually depends on the number of dogs living in the household. My research has a surprising number of applications. Firstly, we can use this to better our ability to assess and improve companion dog welfare. Secondly, we can try to determine predictors of a strong relationship and hence use this to identify how best to match dogs and humans, particularly when we're thinking about service dogs and therapy dogs. And thirdly, we can use this information to help us understand how humans and social animals, how they manage their stress levels in social situations. Thank you.
In this world, there's a small group of people whose job is very demanding and requires multitasking skills. They usually sit in the booth, listen to the message in one language, and comprehend the message. At the same time, they produce the message in the other language to the audience. This is called simultaneous interpreting. Since the introduction of simultaneous interpreting to Nuremberg in the Second World War, this mode of interpreting is widely used at high-level meetings or in organizations such as UN or EU. It's very interesting to notice that most of the European interpreters usually required to work only from their second or their third language to their mother tongue. However, this is not the case in Chinese market. For example, Chinese interpreters need to work from English to Chinese or vice versa. Based on this phenomenon, my research question is, to what extent does directionality influence the interpreting quality and interpreting process in English-Chinese simultaneous interpreting? To answer this question, for my research, I invited 10 student interpreters with 1 to 4 month training and 10 professional interpreters with 1 to 5 years experience in this field. Each interpreter needs to simultaneously interpret one English to Chinese and one Chinese to English speech. Both of the speeches are delivered between 11 and 15 minutes, cover the topic of gender equality, and they are delivered by native speakers. After each interpretation, the interpreter needs to have a retrospective interview to reflect their performance as well as talk about the specific problems they met in the interpretation. The whole process is recorded, transcribed, and annotated for further analysis. So, based on the analysis of the results regarding interpreting process have shown that directionality might be a potential factor that influences the performance for both professional interpreters and student interpreters. However, professional interpreters might be more skilled to cope with the challenge based on their rich experience. For next step, I'm going to analyze the impact of directionality on interpreting quality. Upon the completion of my research, I hope I could offer some new insights on teaching and training in English-Chinese simultaneous interpreting, as well as help student interpreters enhance their skills as well as be prepared for their future development. Thank you.
What would you do if you couldn't recognize your children or your husband and wife when you're getting older? What if you couldn't hug them? Yes, this is terrifying, but these are the symptoms of the two most common neurodegenerative diseases, the loss of your brain cells, Alzheimer and Parkinson's diseases. Due to their super complex nature, researchers are still finding how and why we develop such diseases when we are getting older. And for these reasons, we still not have an effective treatment nor a specific diagnosis for these pathologies. However, in the last decades, a novel association between a disrupted lipid metabolism, the process of making and using fats as a source of energy, and the loss of brain cells has emerged. Not surprisingly, our brain is made of 60% of lipid fats, and fats are fundamental for brain development and survival. And here is where I'm taking action. I want to identify any relevant difference in the lipid content in the blood and cerebrospinal fluid, the fluid that surrounds our brain, between Parkinson and Alzheimer patients and healthy people. To do this, I combine two different techniques, the liquid chromatography, that will help me to separate all the lipid molecules, because yes, there are a lot of lipid molecules, and the mass spectrometry that will help me to identify which lipid is which. As I am pioneering in this field, I dedicated the first 6 months of my PhD just to set up the protocol to make it reliable and reproducible using the blood of healthy people. And I'm proud to say that I finally built a strong protocol, and I'm now moving to the CSF and blood of patients, Alzheimer and Parkinson. If everything goes well, we could enter a revolutionary period where having a diagnosis for Parkinson and Alzheimer diseases will take just a simple and quick blood test. And we could use this information to finally find an effective treatment. Thank you so much.
Okay. The 19th century is a key time period that is rich to explore. At this time, ideas about what is normal began to arise during the Industrial Revolution, and words such as norm, average, and abnormal became part of everyday language, and this informed how disabled people were viewed and treated. Through exploring fluctuations of visibility, such as partial visibility, hypervisibility, and invisibility, it is possible to approach texts such as periodicals, letters, and diaries to explore the lived experience of disabled people. Now, these sources contain layers of visibility. Is it the disabled person speaking, or is someone speaking about or for the disabled person? Assumptions about disability can inform what texts are seen as valid. For example, I'm an ambulatory wheelchair user. When I choose to stand up, does this make my disability any less valid? Now, this is the key question, because when we go in to archives, this can influence what texts are there and can influence a person's perception of disability when someone stands up and when they sit down in their wheelchair. As my slide shows, what one person can perceive can differ from person to person, and this does influence the texts that I find and that are accessible within archives across the country. And of course, obviously, disabled people historically are not wearing high visibility jackets when we go to look for their texts and their lived experiences. Even when the personal writings of a disabled person are found, their lived experience can sometimes be erased. Florence Nightingale described herself as an incurable invalid, and she said that she was entirely a prisoner of her bed, except for periodical migration when overwhelmed with business. For her, there's no conflict between being disabled and working as a nurse, but there is a conflict in how her story is told and taught. And so despite being a really hyper-visible historical figure, her actual lived experience of disability is invisible. Working with and exploring these fluctuating conditions of visibility is the core foundation of my research. When almost 1 in 5 people are disabled, it is vital to ensure that disabled lives historically are made visible. And through ensuring well-rounded historical figures in the general public, perhaps we can challenge some of the social stigmas that disabled people face today. Thank you.
Do you know, when you are in front of a crowd and you have just a meltdown, you forget everything you were supposed to say? Or when you're at home, you were about to do something, then you just realize you don't remember anymore what it was. Now, I study Alzheimer's disease, and a lot of people come to me saying, I'm aging, I'm forgetting things, do I have it? My answer is probably not. It is very common as we age that we tend to forget little things in our everyday life. But people with dementia and Alzheimer's disease, they do have a disorder. Their memory loss is permanent. To us, it's just enough to just take a few step backs, think about it, and then we just remember about it again. But these people, these patients, they don't have this luxury. Now, this disease is currently cureless. However, doctors, they do suggest that having a healthy lifestyle improves our brain function. So doing exercise and certain type of diet, they could improve brain function and brain activity. And this does work for Alzheimer's disease patients as well, but will it be enough to cure it? My work is looking at an hormone named Ghrelin. Ghrelin is produced in our organism during certain type of diets. What it does to our body, it communicates that we feel hungry. So it communicates the feeling of hunger, but it also somehow is able to protect the brain and make it stronger during the period in which we are hungry. So the mechanisms exactly are not well known. However, the mechanism is so clear that if you give Ghrelin to a mouse model of Alzheimer's disease, after several days of treatment, the memory and attention of the mice are so higher compared to they were before that it almost looks like the mice never had Alzheimer's in the first place. Now, how does it work on human? My experiment consists in taking nerve tissue, human nerve tissue, and construct them in the lab. What I do, I then add Ghrelin to this nerve tissue constantly and regularly, like if I was simulating a diet. After a few days of this treatment, I then give them a toxin. In my case, the toxin is called amyloid and is known to simulate Alzheimer's on a dish. So after the treatment with the toxin, I then look at cell levels of stress and metabolism and see whether Ghrelin has improved the condition of the cells. So my results so far show that Ghrelin does protect the cells from stress given by the toxin. And these cells are more stronger and more resistant and tend to support better the stress given by the toxin in itself. So eventually my data will provide a way to figure out how to cure the disease. Thank you.
Hello everyone. Thank you for watching the Swansea University 3-minute thesis competition final. My name is Jill Burgess and I am a member of Swansea University Council, the governing body responsible for setting the university's strategic direction. I am delighted, I have to say, inspired to have the privilege of announcing the winner and the runner-up of this year's 3-minute thesis competition. First, I'd like to thank all of you who have participated in this competition. I'd also like to extend my thanks to those who have supported the participants during the competition process, including supervisors, professional service colleagues, and of course your families. Thank you also to the Postgraduate Research Office, who have made this competition possible during such challenging times. As we have just seen, the 3-minute thesis demonstrates the exciting breadth of research being driven by our student researchers, some of whom are studying for master's degrees, others for PhDs, and others doctoral qualifications. Swansea has an incredible diversity of cutting-edge research taking place, as well as achieving fantastic research outcomes. Our student researchers are getting actively involved with opportunities like the 3-minute thesis competition to share their research and engage a wider audience. Their approaches and findings, I hope very much that you have discovered new and exciting things today, which may inspire you for your own research endeavours. It is now time for me to announce the runner-up and the winner of Swansea University 3-minute thesis competition final. Firstly, the runner-up, I am delighted to say, is Felicity McKee from the College of Arts and Humanities, who spoke about a condition of visibility and disability in the 19th century. Congratulations, Felicity, on your excellent presentation. Next, on to the winner. It is my real pleasure to announce the winner of Swansea University 3-minute thesis competition 2020 is Manuela Paccarini from Swansea University Medical School, who spoke about lipid biomarker discovery in neurodegenerative diseases. Congratulations, Manuela, on your outstanding and very engaging presentation. I was fascinated to hear about your research into the possibility of developing a blood test that could diagnose Parkinson's disease and Alzheimer's. Manuela will now go on to represent Swansea University at the UK 3-minute thesis quarterfinal taking place in July. At the event, entries from all participating UK universities will be judged and 6 will be chosen to participate in the online UK 3-minute thesis final, which will take place in September and which is hosted by Vitae, the global leader in research development. I'd like to take the opportunity to mention that both the winner and the runner-up are student researchers who hold a Swansea University Research Scholarship. These research scholarships are among some of the university's most prestigious and attract to Swansea some of the world's best doctoral research talent. Opportunities like the 3-minute thesis competition demonstrate the thriving and successful PGR student community Swansea is privileged to have. Thank you so much for watching. I do hope you've learned something not only about the groundbreaking research happening right now here at Swansea, but also that you, our wonderful student researchers, have valued the opportunity to demonstrate your passion, skill and expertise to a wide audience and to be recognised for that. Congratulations once more to Manuela and Felicity. Please join me in wishing Manuela good luck for the next stage of the competition, and thank you for watching. If you would like to know more about becoming a research student at Swansea University, then please do explore the university's website. And thank you.